This example says solve the absolute value equation. So remember, when we're dealing with absolute value equations, we're going to have two equations, right? We need to create the identity or create the idea when the absolute value is going to be a positive value as well as for a negative value. So what I like to do is just kind of do, this kind of section. We need to create our two equations. So 3m plus 2 is equal to 1. And when 3m plus 2 is equal to a negative 1. Now we just use our two-step equations and go ahead and solve. So subtract 2 on both sides, subtract 2 on both sides. You don't really have to go ahead and solve them simultaneously, and probably might be a good idea not to do it that way. But I don't know. That's just the way I kind of started in this case. So I guess I'll run with it. And then, because you're kind of doing the exact same thing, it's just, basically different values. You have one as a positive 1 and the other one's a negative 1. So divide by 3 on both sides, m is equal to a negative 1/3. And in this case, divide by 3, m is equal to a negative 1. Now you can definitely go ahead and test these values. Make sure you're not going to be getting an extraneous solution. But whenever you only have one variable and one absolute value on the left, on like one side, um, you're not going to have any extraneous. You shouldn't have any extraneous solutions. But go ahead and plug them in mentally. Go ahead and check. And if you're unsure about it, then it might be something to like work out along on the side. But I think a lot of times, if you're just kind of doing the mental calculation, you can see how this is going to make negative 1/3 as well as negative 1 both make the equation true. All right, what about this one? Now, this one we have a variable on both sides. So this one I'm going to be very hesitant of looking for extraneous solutions. So again, we still need to check out our two cases, right? So we have our first case where f plus 3 is equal to a 2f plus 4. That's case number 1. And then our other case is going to be an f plus 3 is equal to a negative 2f minus 4. Now, basically what I did here is I just negated the left-hand side, 2f plus 4, and I distributed it, okay? So just make sure when you do distribute that negative, you distribute it to both of those terms. All right, so in this case, let's go ahead and subtract an f over here, and let's subtract a 4. So therefore, that's going to be what? A negative 1 is equal to an f, okay? Now, again, we can just plug this in. Like, let's go and mentally plug this in, right? So absolute value of, let's see. So we'll do I'm going to use parentheses, negative 1 plus 3 is equal to a 2 times negative 1 plus a 4. All right, let's see if this works. Negative 1 plus 3 is going to be, negative 1 plus 3 is going to be a 2. Absolute value of 2 is 2. And negative 2 times negative 1 is negative 2. Negative 2 plus 4 is a positive 2. So you can see how this one works out. So we're good to go. Even though I wrote my 2's completely different. Didn't mean to do that. All right, so on this one here, let's add a 2f. Add a 2f, so I get a 3f plus 3 is equal to a negative 4. Subtract a 3, I get a 3f is equal to a negative 7. Divide by 3. F is equal to a negative 7/3. Okay, that does not look like very much fun to go ahead and plug in, but let's, all right, I guess I'll go ahead and do it. I'm going to have to do the work over here because it is going to take a little bit of work here. Actually, you know what? One thing I can do. Let's do this. Absolute value of a negative 7/3 plus 3, okay, equals a 2 times a negative 7/3 plus 4. All right, run out of space, but that's okay. Now, in this case, let's go ahead and add these up because if these are going to be negative, well, then I know if this is going to be negative on the right-hand side, then I know it's not going to be equal to there because remember, the absolute value of anything is always going to be positive, right? So if this gives me a negative value, I know this is going to be an extraneous solution. So what I have is a negative 14 over 3. And then over here, if I rewrite 4 as 4 over 1, if I put this with the denominator 3, that'd be a what? A 12 over 3? So plus a 12 over 3. Now look at over here, guys. See, look what happens. Negative 2 over 3. I was right. No matter what you plug in for the absolute value, you're never going to get a negative value. So therefore, this is an extraneous solution, okay? So this is what we call an extraneous solution. Therefore, the only solution to this equation is going to be when f is equal to negative 1, okay? So that's extraneous. So look out for that. In this example, we have one variable, right? But it looks like we have some operations outside the absolute value. So kind of like following the order of operations, what we want to do is apply the operations outside the absolute value first, and then you can use your two case. So don't ever do the two cases for absolute value until you have that absolute value isolated. So in this case, I'm going to subtract a 4 on both sides. So I have a 2 times the absolute value of a 2y minus 6 is equal to a positive 4, right? So I'll divide by 2, and now I have an absolute value of a 2y minus 6 is equal to a positive 2. Okay, so now I can do my two cases, right? So I have a 2y minus 6 equals a 2, and I have a 2y minus 6 equals a negative 2. Okay, so then I'll add a 6 to both sides, and I have a 2y is equal to 8. Divide by 2, y is equal to a 4. Over here, I can add a 6 to both sides, and I have a 2y is equal to, wait a minute, what did I do here? That's not right. Is that right? Oh yeah, 4, right? And then divide by 2, I was like thinking, I did the same answer in my head. And then y is equal to 2. So now let's go ahead and mentally check, make sure those work. Now, again, the cool thing is you don't need to check back to this equation. You can just go back and check originally here to make sure that it works. Because this is all this equation is from here to here is just a simplified equation. Okay. But the absolute value, you're going to have the exact same solutions for this equation and that one. This one just has a lot more work to think about. So I'm going to plug in a 2 and a 4 mentally into here, and you can see that they are going to work.